attention, as we explored in the last piece, is a resource. A viable, finite, depletable cognitive resource, unevenly distributed across the demands of any given day. But there is a prior question that the discussion about resources doesn't quite reach. What is the terrain that resource has to move us across? Because not all terrain is flat, and the shape of the ground we need to navigate matters as much as the state of the tank. This is a piece about uneven terrain, about what it means to have a cognitive architecture where the peaks are high and the valleys are low, and about what gets lost when the systems that evaluate us were designed for smooth landscapes. Most of us were brought up in environments where competence was assumed and expected to look even, solid across the board, consistent under any conditions. School was the first place this assumption got built into the architecture of daily life, and it never really left. The same 50-minute period for every subject, regardless of whether the material demanded fast recall or slow reflection. The same seated, quiet, forward-facing format for a math lesson and a discussion of a novel, as though the ideal posture for learning were a single fixed thing. The same report card, term after term, stacking grades from entirely different domains into one overall average, as though a 95% in one subject and a 60% in another were simply two data points on the same line rather than evidence of two very different things happening in the same mind. The tests followed the same logic. A written exam under time pressure was treated as equally fair for every subject and every student, regardless of whether the content being tested was the content actually being measured, or whether the format itself, the timing, the silence, the handwriting demand, was quietly testing something else entirely. Falling short in one class and excelling in another was rarely read as information about how a mind was built. It was read as inconsistency and quickly explained away as effort and discipline in one place, laziness and resistance in another. But this is not how most human minds actually work, and it is especially not how neurodivergent minds work. The gap between what we were taught to expect or even strive for and what actually shows up in a mind has a name, and it has been documented for longer than most people realize. What researchers have come to call a spiky profile today is not a compromised version of a level cognitive profile. It is a different shape of intelligence entirely. Significant capacity peaks in some areas, genuine valleys in others, with a distance between them often far greater than what neurotypical profiles tend to demonstrate. Exceptional pattern recognition sitting next to unreliable working memory. Deep analytical capacity alongside difficulty with executive sequencing. Extraordinary perceptual precision and poor tolerance for sensory overload. These are not contradictions. They are the same architecture viewed from different angles. A spiky profile is not a broken average, it is a different intelligence distribution. Or you could think of it this way: an evenly distributed cognitive profile, a neurotypical person in a neuronormative environment, is like a hiker on a well marked trail. The terrain is relatively predictable. The obstacles are known in advance, and the main question is, how much energy do I have, and is it enough for the distance ahead? A spiky profile is a different kind of journey entirely. The hiker is navigating steep peaks and deep ravines, terrain that shifts without warning, where the path that looked passable from a distance turns out to require a full climb, a long detour, or crossing a stream that wasn't on the map. The size of the energy tank still matters, but it matters less than the shape of the ground, because the ground keeps changing the question, because the map is not the territory. What looks like the same walk on paper is a fundamentally different cognitive and physical undertaking. The energy calculation is much more complex. Every step involves reading conditions, weighing options, managing uncertainty, and making real-time decisions about risk that the marked trail simply does not ask from the person walking it. This complexity is not a symptom, it is the actual landscape. For most of the last century, cognitive ability was a number. One number on one line with one direction of travel. Higher meant better, lower meant worse, and the entire range of human mental functioning could theoretically be placed somewhere along that axis. The IQ score was not just a measurement tool, it was a worldview, one that assumed that intelligence is something that a person can have more or less of. That worldview is dissolving. The research has been pulling in a different direction for decades, and the cumulative weight of it is difficult to ignore. What we call intelligence has always been a profile in disguise. The IQ score was always a numeric summary imposed on top of a shape. Yet, the shape is what actually matters day to day. The shift began with challenges to the single axis model itself. Gardner's theory of multiple intelligences and Sternberg's triarchic model, both influential frameworks rather than settled psychometrics, made the foundational argument. Cognitive ability was never one thing. That the same person could reason brilliantly in one domain and struggle in another without it being either a measurement error or a contradiction. That the number had been averaging over something far more interesting. Executive function research deepened the picture, establishing that working memory, inhibitory control, and cognitive flexibility are not just different names for the same capacity. They are functionally separable systems that can run at very different levels inside the same person, and developing one does not automatically lift the others. The standard tests eventually caught up to this, even if they didn't fully embrace it. The most widely used intelligence test today, the ones psychologists still administer to children and adults, don't actually produce one number from one measurement. They produce it from several. We have a separate score for verbal reasoning, another for visual and spatial reasoning, another score for processing speed, and another for working memory. 4 different channels measured separately, then quietly averaged into a single figure at the end. In other words, the test itself already knows the mind is multidimensional. It just buries that knowledge in the final step when it collapses 4 different pictures back into one number. But even 4 channels understate the picture, in fact, especially once we look past standardized testing into what autism and ADHD research has actually been measuring. The WISE and WISC tests were built to assess general cognitive ability, not the specific texture of a neurodivergent mind. When researchers study autism and ADHD directly, at least 4 more domains show up again and again as distinct, separately identifiable dimensions, not part of any IQ score, but no less real for it. A large-scale meta-analysis spanning 235 studies and over 14,000 participants found consistent executive function differences in autism, including planning and sequencing specifically, as one of the most replicated findings in the field. Sensory processing is now significant enough that it entered the diagnostic criteria for autism directly, with its own body of neuroscience behind it. Emotional regulation. It has its own dedicated clinical literature, distinct from general mood or behavior, describing a specific and well-documented pattern of difference and pattern recognition. The perceptual strength already discussed in Motron's work is a fourth axis entirely outside the scope of any standardized intelligence test. None of these 4 are what a WISE or WISC score measures. They come from a different parallel body of research, one focused specifically on an individual's functional and behavioral profile rather than general cognitive ability. But they are no less rigorously documented, and for understanding what a spiky profile actually looks like day to day, they matter significantly. The neurodivergent data made the multidimensional picture impossible to set aside. Autism and ADHD literature, from Happy's work through Motron's perceptual processing research to the Wilson meta-analysis, shows those distinct cognitive channels not just separable, but dramatically diverging, peaks and valleys further apart and more consistently so than in neurotypical profiles. Read together, these lines of research are not competing theories to choose between. They are partial views of the same object, each adding resolution to a picture that the single linear axis, the single linear worldview really, could never produce. A mind is not a level, it is a distribution. A mind is a complex and dynamic neurocognitive system with its own internal logic, its own terrain, its own conditions for functioning well. In the emerging intelligence framework, cognitive asymmetry is not an anomaly. It is the clearest demonstration yet that the old framework was measuring something for sure, just not what scientists initially thought it did. That shift changes what a fair comparison even measures. The old question ranked people by their average, one summary figure against everyone else's. The more honest question is not about averages at all, it is about variability. How far a person's peaks and valleys sit from one another, which domains hold steady under pressure and which give way, and how much the whole shape moves when the context changes. Two people with an identical average can carry completely different architectures. It is the underlying profile, not the numeric average, that determines what each of them can actually do, where, and how. The question worth asking isn't how much intelligence, it is how is it distributed and under which conditions does it hold steady. The performance evaluation systems most of us operate inside, schools, academia, workplaces, and organizations, were not designed around the actual range of human cognitive architectures. They were designed around a cookie cutter assumption that a capable person performs consistently like a smooth shape. This assumption was never accurate, and it is particularly costly for individuals whose strengths are deep rather than broad, context sensitive rather than condition dependent, and bottom up rather than demand driven. The result is a systemic evaluation problem. There is no denying that an autistic individual who completes Raven's matrices, a nonverbal analytical reasoning test, 40% faster than neurotypical peers on average, is demonstrably performing at an exceptional level. The same individual asked to complete a verbal reasoning test that requires processing through auditory instruction may score significantly lower, not because their reasoning capacity has changed, but because the channel through which the task is delivered is the wrong channel for how their processing is organized. This is not an isolated finding from a single lab. A 2023 meta-analysis pulling results from over 1,800 autistic and ADHD individuals across 18 separate datasets confirmed the pattern at scale. Autistic profiles consistently show typical range or above scores on verbal and non-verbal reasoning, alongside a measurable persistent gap in processing speed. The peaks and the valleys are not anecdotal. They are not noise around a single average signal. They are a replicated population-level signature of a different cognitive architecture. Common evaluation systems register this as inconsistency, sometimes as evidence of disability, rarely, if ever, as evidence of an evaluation design problem. Because what we call inconsistent performance is almost always consistent with something. The question is whether our measuring tools are sensitive enough to find that something. Part of the story stays at the individual level. The neurodivergent person who struggles to demonstrate their capability inside systems not designed for them. But there is more to it. When evaluation systems are designed for the average, they systematically underestimate the peaks. The job candidate who would have solved the problem the entire team is struggling with does not get hired because the interview format penalized their verbalization speed. The nurse who would have caught the medication error before it reached the patient is burning through her available capacity, managing the fluorescent lights and constant alarms of the ward. The teacher's aide, who notices exactly which small classroom change would help three struggling students at once, is never asked because the staff meetings run unstructured and fast. These are not edge cases, they are the ordinary operational cost of designing systems for a cognitive average that most individuals on any given day are not actually hitting. And there is also a compounding effect we don't talk about much. When the peaks are not recognized, the valleys become the whole story. And when the valleys become the whole story, the standard response is to demand more effort, more compensation, more performance of a consistency that neurodivergent minds do not have in the form that is being asked for. This is precisely the condition under which spiky profiles collapse, not because the peaks disappeared, but because the energy that was powering them got redirected into performing a smoother shape. The uniformity assumption does not just fail to identify the peaks, it actively starves them of resources. And when an environment consistently fails to recognize what a person's architecture makes possible, the person eventually stops expecting it to. They stop offering the observation that does not fit the meeting format. They stop applying for the role or the project that would have used their actual strength because the application process has already taught them what kind of profile gets through. This is not modesty. This is not lack of self esteem either. And it is definitely not a skills gap. This is a learned, accurate prediction about which parts of the individual the evaluation framework of the school, the team, the organization is exclusively interested in. What gets lost when spiky profiles go unrecognized goes far beyond the obvious, all the way to missed opportunity. The unbuilt thing, the uncaught error, the outdated pattern that persisted 2 cycles longer than it should have. We humans don't register missed opportunities and their magnitude as thoroughly as we register and fuss over obvious successes. Do we? This is not a marginal inefficiency. Across research, technology, design, and any kind of analytical work that depends on noticing what does not yet have a name, a meaningful proportion of the people best equipped to do that noticing are operating inside systems that register their actual capability as a liability to be managed rather than an opportunity to put a peak to work. Some of them get filtered out before they even reach a role, a project, a team where the peak would matter. Some get selected and then spend the bulk of their available capacity performing a consistency they were never going to have, leaving little left for the core work that consistency was supposed to protect. Either way, the cost is the same, a structural loss of exactly the kind of thinking and doing that homogeneous systems cannot generate on their own. A 2025 survey of neurodivergent employees found that 93% believe standard hiring practices, time tests, unstructured interviews actively work against them. And the cost often runs in direction the system doesn't even anticipate. One recent study found autistic employees report measurably lower rates of moral disengagement. The self serving bias associated with unethical, workplace behavior. A peak that has nothing to do with autistic pattern recognition or technical precision, and everything to do with the kind of organizational integrity that is difficult to train for and easy to lose. Talent recognition is not a sorting problem, it is a design problem, and the system currently doing the sorting was designed to identify one shape. Recognizing neurodivergent talent, then, is not an act of generosity extended downward from a system that already works. It is more of a correction, an acknowledgement that the system's definition of capability was too narrow to recognize what was already there. Montron's work with autistic scientists is instructive here, not as inspiration narrative, but as evidence of what different cognitive organization produces when it has appropriate conditions. Autistic researchers in his lab were not there despite their autism. They were there because of the specific perceptual and analytical capacities that autistic processing tends to generate. The ability to hold and process large datasets simultaneously, pattern recognition that does not conform to prior expectations, near infallible memory for methodological details, and a bottom-up epistemic orientation that stays closer to data than to theory. These are not compensatory strengths. They are the actual features of minds that process the world differently and in certain contexts more effectively. The research consistent picture is not that neurodivergent individuals are gifted despite their challenges. It is that the so-called challenges and gifts are two sides of the same story. For a long time, the standard evaluation question has been, does this person perform consistently across the full range of tasks this role requires under the conditions we have theoretically established in the format we have chosen to assess them? This question is not neutral. It encodes a specific theory of competence, and that theory excludes a significant portion of the actual range of human cognitive profiles. A more honest question is, what does this person's mind make genuinely possible in the right conditions, and what would those conditions need to include? Recognizing a spiky profile is not about accommodation as exception. It is about evaluation design that is actually calibrated to the range of minds it is meant to assess. Asymmetric minds are not problems awaiting normalization. They are different distributions of capacity, each with its own terrain, each with its own best conditions, and its own genuine peaks. Designing for them is the precondition for accessing what they actually have to offer. We do not need more effort applied to the valleys. We need evaluation frameworks sensitive enough to find the peaks. Moving on, the question is not how to flatten out spiky individuals. Our real challenge is to create environments where the peaks can do what only peaks can do.